Hello, everyone, and thank you for attending today's webinar, Kubernetes Security Best Practices. Before we get started, I want to cover a few housekeeping items. If you have any questions during the webinar, you can go to the Q&A button at the bottom of your screen and submit your question at any time during the session. We will have a Q&A session at the end of the webinar. The on-demand version of this recording will be available after the webinar. And now I'd like to introduce our speaker. Connor Gorman is a principal engineer at StackRox, where he designs and builds the StackRox Kubernetes security platform. Lately, he has focused on helping users understand the complete risk context for their Kubernetes workloads and enabling them to implement effective security controls to mitigate those risks. Previously, he revamped significant parts of Medallia's worldwide data center and application deployment architecture. And now, here's Connor.
Hey everyone, thanks for joining the webinar today. I think as Debbie alluded to, we're talking about Kubernetes security best practices. And so just jump into it. So what we'll cover today, talk about general Kubernetes hygiene, talk about some workload best practices. I'll go through a demo of how those workload best practices translate into actual stopping real live attacks. And then I can take any questions you guys have there at the end. Cool, so what are we doing here? Kubernetes is coming. I think a large portion of everyone's organizations are moving towards it. Some of you are probably pushing Kubernetes at your organization, seeing the benefits, and some of you are probably getting Kubernetes pushed onto you, right? And wondering how you're going to manage, especially the security of Kubernetes. And so this would be an overview today, and of course, we've got a lot more content for you down the road. So starting with Kubernetes hygiene, what's the first thing to start with? Upgrading. Upgrades are never super fun, but in general, the Kubernetes maintainers maintain vulnerability patches for the last 3 releases. So at this point, that's 1.16, 1.15, and 1.14. And the last place you want to be when a vulnerability comes out is trying to roll out new infrastructure and roll up infrastructure. If you think about the time that Kubernetes deprecated etcd2 in lieu of etcd3, right? You don't want to be rolling out large data plane upgrades for a vulnerability because you usually want to plan those things out. So you don't want to be surprised by a vulnerability or not having support for something. So always be sure to upgrade. One of the challenges with that is knowing when to upgrade. How do you know that there's a new version out? I personally love this Google group. It's not too spammy. They send a lot of updates, but basically it'll let you know when there's a new version, if there's any security announcements, and it can always just help you track what's going on in the Kubernetes community. And so that way you can see if you get a new CVE, what's your impact level. So I think that's really important, and it's just like kind of an easy place to go for Kubernetes announcements. Kind of on a more practical level, and kind of like more traditionally, you want to do with Kubernetes, right? It's an orchestrator that runs on top of what I would consider somewhat traditional infrastructure of VMs or servers, right? Is make sure you're controlling the network access to the sensitive ports in Kubernetes. Specifically in this case, the ports used by the kubelet, right? And then make sure you try to limit the access to the Kubernetes API server itself. So there was a recent CVE that came out that actually allowed unauthenticated DDoS to the Kubernetes API server. So you really want to make sure you put this behind a firewall and make sure that you're restricting the IP blocks that can access it, right? Put it on a VPN to ensure that no one with unauthenticated access can even hit the API server because there's always new DDoS attacks coming out, and in general, it's a really good idea to make sure you've restricted that to a set of trusted networks and people. In terms of node security, just this is a general infrastructure best practice, but make sure you minimize the access to Kubernetes nodes, right? If people have root on nodes, right, they can Docker exec, they can look at the secrets that might be mounted or the volumes that are mounted, right? And they pretty much have access to your infrastructure. So restricting access to these nodes is paramount, and making sure that the people who do have access really, really need that access. Something to look at and look for in future releases of Kubernetes is that they put into alpha ephemeral containers, which takes away the emphasis on having to make sure you have debugging tools on the node or in the pods themselves. And the ephemeral container can attach to a running pod, and you can run debugging tasks or look at logs. And this should really help avoid a situation where people need access to the nodes or even the ability to kubectl exec into containers. So it's in alpha now, something to look at moving forward. And finally, from a Kubernetes perspective, what we've done is you've restricted the access to the API server, you've restricted the access to the nodes themselves, right? And then let's restrict access to the developers and service accounts about what access they actually have within an API server. So the way that they've created this is basically you have subjects, which is the who and who can do what, right? The API resources, which is the resources within Kubernetes that people can access, and then kind of what you can do to those resources. And I'll jump into this in a little bit about namespaces and how they can help with your RBAC. But generally, you want to make sure we set these up. So as you're kind of going through your Kubernetes journey, a lot of people start with everyone having cluster admin. You're trying to figure out, what am I doing with Kubernetes? How can I launch resources? And make sure that you have maximum velocity when you're doing that. But once you've kind of passed that stage, what you really want to do is take a retrospective look and say, do these administrators or developers need this specific access? Is their access a little bit too widespread? And try to rope that back in. And so that's something to think about as you're kind of moving through your journey, especially with older clusters that may have more permissive RBAC. So this is just kind of a quick overview of the Kubernetes orchestrator itself and how you can kind of secure the actual physical orchestrator. But we're going to jump into securing your workloads, which I think is a huge part of Kubernetes security specifically, because now we have developers launching applications on top of Kubernetes. And how do they secure those, and how can you help your developers secure those? So a pretty simple one, pretty straightforward one, but leverage namespaces. Namespaces for RBAC, for example, are super useful where you can segment specific teams. So imagine you have a payments team, an operations team, and a front-end team, and you really want to ensure that they don't bleed data between them, and that you can make sure that they can't access each other's resources, right? And some of it might be customer sensitive. It's really useful for multi-tenancy to make sure that you have customer one, professional services for customer one, and professional services for customer two, and that they can't access each other's instances. In terms of network policies, which we'll go into kind of at the end there in the demo portion, you can really see that you can segment between tenants so that you can really ensure for compliance purposes that they can't access each other's instances or databases. I love it for resource usage tracking to see which team is spending the most of your money and the most of your resources. And then finally, I think it really makes kubectl results much more easy to read and much more sane to walk through, where you're just looking at, hey, what resources exist in this specific namespace, and kind of just is a nice segmentation as opposed to one big chunk of resource in the default namespace. So namespaces are super important. They're a really nice logical segmentation on top of Kubernetes. I strongly suggest that you use them and don't use the default namespace. So when it comes to Kubernetes, it's kind of like an onion. There's a lot of layers when it comes to the context that Kubernetes provides. And so I think kind of the base level is it starts with an image, right? And then you go into a container, which you then roll into a pod. And then in Kubernetes world, you kind of roll into deployments and daemon sets, which are basically ways to run these pods, right? Where a deployment is saying, I want to run a pod with X number of replicas. A daemon set is more of an agent approach. We are talking about, I want to run this pod on every single node, right? So starting with the image, you're really looking at the contents of that image. What are the vulnerabilities that exist in the packages? Which registry is it from? Is it a trusted registry? Which files exist that could be used by attackers or for debugging purposes, right? And then you roll that into a container, and then it's, okay, where am I running this container? Am I running it in test versus prod? Do I have separate clusters for these things, or are they one cluster? All right, which businesses are launching these specific clusters and using these for their CI/CD processes, right? You're looking at labels and annotations. I think these are a really critical and awesome part of Kubernetes, where basically you can annotate your resources. I love using it for the owner of a particular resource, so you know who the point of contact is. It could be an email, it could be a team Slack, a webhook, and that would just help security and ops look at a specific resource and say, okay, I know it belongs to this team, and here's the point of contact for that. So if there's an incident, either performance or security, you automatically loop back to a specific person and a concrete action that you can take, right? So that was kind of metadata around pods. And then as you jump into specific privileges and access, right, you can see which, how much access does a particular pod have in terms of the API. That will be given by a service account. On the host, what is it running as? Does it have access to any host mounts, right? Like data that's persisted, potentially secrets, right? So you're looking at kind of the risk around a particular pod and its configuration. You jump into a network segment where you're looking at, okay, now that I have this pod and it has this access, what can it talk to? Can it talk to the internet? Which other pods can it talk to? And effectively, you're kind of defining the blast radius of a particular pod. So this pod got compromised, who could it talk to, and who could it try to compromise from there, right? If you're running a critical database, it's really nice to have a couple levels of indirection in terms of networking, as opposed to a front end that gets hit from the internet and immediately talks to a database, right? So that you kind of defining how far, like I like to think of it as like how many degrees from Kevin Bacon you are, right? Is like how many degrees from the internet or access is your critical pods. And then finally, a pod and a container and an image all lead to one thing, which is basically just running an application. And so the actual behavior of that application is really important. So what does the application actually talk to? What processes are actually launched? What are the actual executions? What files are written, right? And so this entire kind of context here needs to be taken as a whole and think about how you evaluate risk in a Kubernetes world where you're looking at kind of all of these different components. So in terms of like concrete configurations to explore, I'm definitely going to highlight the top three today: a read-only root file system, Linux capabilities, and network policies. But there's many, many more knobs you can turn on containers and Kubernetes itself. Looking at host mounts, you can not mount service accounts into every container. You get environment variables, and resource requirements. So if we jump into kind of the read-only root file system and discuss what is a read-only root file system, it's kind of exactly what it sounds like. So effectively what you're doing is you're making the file system inside a container read-only unless you've specified it as a volume. And so in this case, example, I've seen that I've made var log an empty directory, which is either can be a RAM-based empty directory or one that's just mounted inside the container file system but marked read write. And the rest of the file system is read-only. This can be really important because a lot of attackers assume that /temp is read-write. And the reason for this is that in kind of like traditional servers or VMs, you're running a lot of different processes. A lot of them require the ability to create a temp file system or a temp file, and it will always write to /temp. So attackers make use of this and will drop payloads there and execute them. And in a container world, it's possible to not make it read-write because you know exactly what your application is doing. Instead of running a large number of processes inside a VM, you're running just a single application. Typically, it's a process or two, and you can kind of understand exactly what actions it's taking. So I'll jump in and show why this matters. So I've got a GKE cluster running here, and I'll deploy a Strut server. The Strut server has a critical vulnerability of remote code execution. And this is actually the same server that was the cause of the Equifax breach. So I've got it running now, and I'll go ahead and run the exploit. So what this exploit is doing is it's crafting a header, sending it to the Strut server. It downloads a minor-d binary from the internet, untars it, and runs it. And so at this point, you can see that we're running minor-d in our container. Not the most malicious thing someone could do, but it's definitely stealing our resources. And you can imagine this could be used for much worse purposes. So what I can do here is I'll show you my read-only struts YAML that I'm about to apply. And I've just set the security context read-only root file system to true. And inside the Docker file, I've made a volume at user local Tomcat because Tomcat does need to write temporary files. So it's not completely a root file system. And I will replace this one here. So I've applied a new YAML for Kubernetes. It's making the file system read-only. We'll wait for this guy to come up real quick. And then we should see that our exploit actually fails. So I'll run the exploit. Right? And so in this case, we tried to download the minor targz into slash. And even slash was a read-only file system. Whereas, if they had known that user local Tomcat wasn't, then they could write it there. But, a lot of these attackers are just running scripts against an environment and checking for specific vulnerabilities. And so they're not really that complex into looking into, hey, is this file system read-only? Where can I find something that's read-write? So in this case, we've thwarted an attack with, basically 2 lines of YAML. And so it's really important, and it's a really easy way to reduce the attack surface of your container. The hard part of this is figuring out, how do I know that I can make my application read-only, and which paths do need to have volumes? So what I've done here is I just ran an Nginx, right? Obviously I didn't write Nginx, so I don't know where it writes temporary files to. And I ran it on my local Docker for desktop, and I just ran a Docker Diff. So Docker Diff will look at which files have changed over the lifetime of a container. And so what we can see here is that there's kind of 2 main areas to look. The run secrets, Kubernetes is handled by Kubernetes, so you don't need to worry about those. But /run nginx.pid is definitely something to worry about, right? So we should make that read-write, because Nginx will write out to there. And then also it looks like, in this case, the root of a volume here is var cache nginx. So in this case, if I used 2 volumes and made var cache nginx read-write and then /run read-write as well for the nginx.pid, then nginx itself could be containing a read-write or read-only file system, excuse me. And we could easily reduce the attack surface of that. So this is just one easy way, if you're using local dev, that you could look at specific containers you're running and seeing which files are actually being written at runtime. There's a lot other ways you can do this. You can look at a live monitoring system that's looking at files, but this is kind of a simple way if you're just checking out and trying to reduce the attack surface of some of your apps. Cool. So the next configuration that I would love to discuss are Linux capabilities. And Linux capabilities are one of those knobs that you can turn that's super powerful, but a lot of people don't really know how to use them or haven't had a ton of experience with them. And so what Linux capabilities are is like, the idea was that basically root was a little bit too powerful. And so what they want to do is split the root superpowers into a series of capabilities that are more fine-grained. So in this case, you have something like capfowner, capchown, capnetraw, right? And these are all used by pretty common Linux utilities. But typically these aren't run inside a container. And so what you can do is you can drop these capabilities and potentially block some attacks that are trying to use some of these modifications. For example, capnetraw uses raw sockets. Typically your applications aren't using raw sockets. So to monitor and figure out what Linux capabilities you need, this is a little bit more complex. I used eBPF probe written by Brendan Gregg from Netflix. And we are looking at a function called capcapable, and we'll see which capabilities are trying to be called by specific applications. So in this case, this API server, which is the Apache Struts server that I was running, it actually required no capabilities. So the capabilities we're seeing on the screen are due to the tar that was run from the remote code execution. So theoretically, if we drop the capabilities, right, these capabilities here, then the tar will be unable to run, and then we should block the attack that downloads the minor D and makes it executable and runs it. So as we jump into, I can demo that there. So I'll just go ahead and cat this guy. And what I've done here is inside the security context, I've dropped all capabilities. And the reason I can drop all capabilities is because Tomcat doesn't use any capabilities, but also the port that we're using, 8080, is an unprivileged port. So you do need net admin if you're running in a privileged port. So for example, if you're running port 22, you would need net admin. Though don't run port 22, SSH is not something that should be contained in containers. So I'll go ahead and modify my current application that's running. Just apply this, let the API server come back up, and then we'll rerun the exploit and see what happens. Cool, so it's back up running. And now I'll go ahead and run this exploit. So the download in this case actually ended up succeeding. Unlike last time, when we wrote it to /minor.targz, and then it failed the ownership change. So in this case, you can see that basically just dropping these Linux capabilities that weren't being used or exercised anyways ends up blocking an attack that doesn't know that these capabilities are dropped. A lot of times this is enough for an attacker because they're just running a script, right? And if their script fails, then they'll back out and move on to the next potential target. So these are just easy mechanisms where you're dropping capabilities you're not even using, right? You're basically dropping privilege and lowering the attack surface of your container. So finally, the one I would like to discuss, right, is network policies. And so the way I think about kind of an attack, right, in this case, we blocked the file write, the payload drop. We've blocked the changing of the ownership and the capabilities that we don't need. And then finally, it's like, okay, how do we just block the network access completely? And so network policies are super specific, and you can basically create a firewall between pods or between internet access points. And the way that Kubernetes has this is that you can specify labels on top of pods and then restrict access in that mechanism. So in this case, this particular YAML, example YAML here, we have a pod selector. It's matching the labels app web. So any pod that has that is what this will apply to. And then it allows ingress, so it allows connections from one of these locations. So from a namespace selector standpoint, we're selecting a specific namespace. We're selecting one which is team operations, so it's probably an operations namespace. And then the pod selector, the type has to be monitoring. So imagine you're running Prometheus inside a namespace that has the label team operations and it's scraping endpoints on this web server. We will allow ingress from any pod that has monitoring, right? So we will label Prometheus with a label type monitoring, and that will have access to this web server. And so in this case, this would be the only one that has access to our web application. So in practice, right, you can also block ingress and egress. In this case, we'll go ahead and block egress. So if I go ahead and apply a network policy, and I can cat this network policy to show you what I've applied. That's not the network policy. You can see that we've selected our API server, right? And we've specified a policy type egress. Now we haven't specified any rules for this because we're basically blocking all egress. Our web server on the internet should not be reaching out to the internet. We should only be receiving connections. So the impact of this is when I run the exploit, right? We'll basically see that this starts to hang. And so this wget is still running because it's actually you just waiting for a timeout. So in this case, we blocked the access to the internet, and wget is just waiting for the timeout, and it'll get a gateway timeout. So these are kind of like 3 different ways that you can lower the attack surface of your container and pod. And it's actually, one of them would have been sufficient, but all 3 will block a huge variety of different attacks. And this is almost for free because you're not changing any of the actual runtime capabilities of your application. Instead, you're just restricting the attack surface down to exactly what your runtime data is actually using. So these are just kind of like 3 really cool ways that you can drop privilege and drop the attack surface of your containers. So the final thing to remember is that security is hard, right? Some of these capabilities are hard to use or can be a little bit more difficult, but any attempt and effort that you make in reducing the attack surface of your containers is definitely worthwhile and can have a big impact on your organizations and overall security posture. Thanks. I think we can take questions now.
Thank you, Connor. It's now time for Q&A. So if you click on the Q&A button, you can enter your questions there. Our first question, how would you suggest we go about automating some of these workload security practices?
Yeah, so I think a large variety of runtime monitoring is really effective in these areas, right? So looking at the files that are being or like written inside a container, right, can really help, like the read-only file system situation, or you know, actively monitoring the capabilities that are being used, right? If you don't want to use this kind of like at runtime, what you can do is you can give tools to developers to start doing this themselves as they're kind of deploying and generating these YAMLs. So I think that's a big impact on you know, the overall posture, is making sure that you shift left and have your developers start using tools that can give them this information, and then also you can do some active monitoring at runtime.
Okay, let's see, next question. Where and how to set RBAC in this Kubernetes environment?
Right, so RBAC is built into Kubernetes. And there's kind of a variety of different ways, and cloud providers provide it in different mechanisms as well. But you can set it at a service account level if your services do need to access the Kubernetes API. If not, then you don't need to do it there. But then you can set it up for specific users and users that have logged in. So it's within Kubernetes itself, and the documentation is pretty good about like the verbs and the resources that you can access. And RBAC applies to almost every resource.
Okay, next one came into the chat. Can any of these be set as default for the cluster, or do they have to be specified at the app definition?
Right, so these do need to be set at the app definition, but you can use things to enforce this, like pod security policies, which does map to the security context. So if you want to require people to drop specific capabilities or not run as privileged, the pod security policies can be used. They're just basically an emission controller, or there's a variety of tools that provide emission controller access, and then you can create policies live like that. So, for example, StackRox does that.
Thanks, Connor. Next question. When migrating legacy services, how do you deal with issues where connectivity between these legacy microservices may not be well known in order to implement network security, in parentheses, firewalling?
Right. So I think a large portion here is looking at the traffic, and then also kind of like working your way through these. So as you're migrating them, right, you kind of have a unique opportunity of seeing what needs to access what. So the first thing to do for a namespace, for example, is you can set a default deny. And so then you have to poke holes to make sure everything works, right? So as you're migrating these services, you're going to start working through the network connectivity. And you can see kind of like some of the failure modes. Also, there's some really cool tools. StackRox has this, is really awesome, which is basically you can look at the live traffic that's running between specific pods. And then you can start scoping the network policies to the live traffic that you're seeing. Right? There's a lot of distributed tracing tools that provide at least the network visibility. And then you can scope network policies according to that actual network runtime data, sorry.
Thanks, Connor. Okay, so next question. How do you prevent attacks from inside the cluster considering a shared environment?
Right, so containers do a really good job of isolating between individual containers. But attacks jumping from potentially doing like from pod to pod, jumping through pod to pod. I think network policies are really effective there in terms of just stopping the access from potentially jumping through pods that shouldn't be able to talk to each other. So network policies can really help in that situation. And then making sure that you're not really mounting host volumes and that the isolation is really kept in containers. So try to not rely on things that exist on the host. Okay, well, it looks like that's all the questions that we have for today. I want to thank you, Connor, and thank everyone for joining us today. And did you want to mention regarding other topics? Yeah, so if you guys have any specific topics that you want to hear about, feel free to put them in the Q&A, and we can address them in future webinars. We're always interested in making sure that you guys are getting content that you guys want to hear or are really interested in and want to know more about.
Absolutely. Or email Connor or email marketing@stackrocks.com. Thank you so much for joining us today.